Equations in 3 variables. They're difficult. We're going to do them in the easiest way possible by expanding on some things we've already seen before. And here's where we're going to start, with a system of 2 equations in 2 unknowns. We've already learned several methods of solving a system like this. Our original method was to draw a graph of each line, pick the spot where they crossed, and that was our answer. But graphing wasn't usually a very good method, so we also used a second method, substitution. We start by solving for one variable. This time y is easier, but we want to be careful with those signs. Then we substitute in the other equation, and that gives us one equation in one variable. Great. We can solve that for x, and then we go back to our earlier substitution formula for y to get our final answer. But the arithmetic with fractions is quite hard. So we also had a third method, elimination. Here the trick was to make 2 of the coefficients the same and then subtract, so we'd be left with just a y term. Then do it all over again for the other letter. In this case, we add positive and negative 3y to get an x term by itself, and then solve for x. If you found any of that material looking strange and new to you, you'll probably want to look at some of these review modules before you go on, because now we're going to make things a little more complicated. We're going to use 3 variables, 3 unknowns instead of 2, which means we'll need 3 equations as well. The whole thing comes out looking rather monstrous. We need to find all 3 letters. Graphing is too hard. We'd have to do it in 3 dimensions, if you can imagine that. So instead, we're going to use a mixture of substitution and elimination. But that problem is a little too hard, so let's start with a slightly easier example. Is this one easier? Yes, it is, because equations 2 and 3 have only the letters x and z. Let's work on those 2 easier equations first. We can solve for x and z the same way we did earlier. We cancel out the z's by adding, and we quickly find the value of x, 7/5. Then, to get z, we multiply the first equation by 3 and the second by 2, and then subtract. The 6 x's disappear. And notice what happens when we subtract a negative 2z. All of which tells us that z equals 1/5. So now we've found the values for x and z that solve the last 2 equations, and we need to find y that will make all 3 equations work. So we take the first equation and substitute what we know, namely the values for x and z. When we go to solve for y, we have only an equation in one variable, which is very easy stuff by this time. Y equals 18/25. We had x and z, now we have y. So this is our final solution, values for x, y, and z that satisfy all 3 equations. You can substitute and check if you want to, but it's better to get it right the first time. The thing to notice as we move to harder problems now is that we've already learned our method. The pattern is going to stay the same. We'll use elimination to get what we worked with earlier. Two equations in two variables. Solve those, then finally substitute to find the third variable. That's what we're going to do with this one. But this time we have to begin by doing some work to get two variable equations. Suppose we pick the first and second equations to work on first. We choose to eliminate the x terms. How can we do that? By making them both 3x. So we multiply the first equation by 3. Which gives us 3x top and bottom. And then we subtract. We are careful with subtracting that negative term, of course. And that leaves us with an equation in just y and z. What we need now is one more equation in two terms. Let's take another look at our original equations. We've already used the first and second. Now let's try the first and third. We have to eliminate the same letter as before, x, which gives us a perfect chance for you to prove that you're following all of this so far. So go ahead and multiply, and then subtract to get rid of x, and then come back and check your equation against mine. Multiply and then subtract to get rid of the x terms. It looks like this. And our second equation in two variables is y plus 14z equals 15. And now we have exactly what we needed, which is precisely what we had when we started work on the previous problem. So let's keep going. We can eliminate y by multiplying by 7. And then subtracting. This time, top from bottom is easier. There's our value for z. Not a very tidy fraction, but it's right. Now we need to find y. You can do that by yourself. You can use elimination again, or you can switch to substitution. I don't really want to substitute since y was such an ugly fraction. So I'm going to use elimination again. First, I want to make both z terms 28, since 28 is the LCD of 4 and 14. Then I can subtract. 49 minus 2 gives me 47y. So now I have a number for y, and we already had one for z, which leaves x to worry about. Let's go back again to our original equations. We want to substitute our number values for y and z. Okay, but we have 3 equations. Which one should we use? Since our answers work equally well in all 3, we'll just pick the first one because it happens to look easiest. We substitute the 3 number values we found, and then we have to solve that mess for x. We'd better multiply by the LCD, 94, immediately to get rid of the fractions. Then, when we solve for x, we have our complete solution to the system of 3 equations. There's a valuable lesson to be learned here. Don't be afraid of awkward fractions. Just use what you learned about working with 2 variables, work carefully, and you'll get it. A question. What kind of earth-shaking problem might produce a system of 3 equations like that? Well, maybe something as important as your friend's bills at the local drive-in theater. We know that everything costs too much, but how much? For tickets, for popcorn, for drinks? You can handle this one now, so go ahead. Choose variables and set up a system of equations. Here's the information again. To keep it simple, I leave all 3 items in the same order. X stands for tickets, Y for popcorn, and Z for drinks. Now, I'm about to show you the 3 final answers to the whole problem. If you want to see the answers and use them as a target to aim at, go ahead and copy them now. But if you'd rather do the whole problem by yourself and then check your answers, the time is right now. One final word. Be sure to check your book for more problems to use for practice. And 2 final words. Good luck.